All right, so this video is going to be recorded on solving, and it's really what we're solving is anything with rational exponents. But the way the book seems to teach it is most of these rational exponents are expressed actually in radical form. So for example, remember that's an exponent, but it's a 1/3 exponent. This is a 1/2 exponent, 1/3 exponent, that's a 1/5 exponent, that's a 1/4 exponent. And actually as you get down this book, they start showing them more in exponential form. Like 1/4, that's just the 4th root, that's all that is. 2/3, that's a 3rd root, but a 2nd power. This is a 3rd power, but a 2nd root, or a square root. So really this chapter is focused on solving rational exponents, but mostly they disguise them in these radicals. Okay, so with that being said, remember if you're going to solve for x, you're really doing PEMDAS. There's an order of operations in which you solve, but you're doing it backwards. So you're starting with anything that's being added or subtracted and getting rid of that. Anything that's being divided or multiplied, getting rid of that. Then any kind of exponents, and then lastly parentheses. Okay, so mainly in this section, you're really going to just get to adding, subtracting, multiplying, and dividing, and your objective is to get this radical by itself. Once it's by itself, then you can get rid of it. So for example, in number 3, you see the radicals by itself. There's a 5x plus 1 underneath it, but you can't touch the 5x plus 1 until the radical on top of it is gone. X minus 16 is below the radical in number 5. Now look at 7. You have a 13 on the outside and a -2. So what I'm saying is you have to get rid of the 13 and then the -2 so you can get that radical isolated. And once it's isolated, you can get rid of it. So let me go ahead and just work through a few of these problems. Remember what I just said. My objective first is to isolate that radical by doing PEMDAS backwards. Then I get rid of the radical and solve it from that point. So first question, is the radical isolated? Yes. Okay, so I need to get rid of that. I'm going to square both sides so I can get rid of the radical. So the square root of 5x plus 1 squared is simply 5x plus 1. And 6 squared is 36. Okay, so now that the radicals are gone, I'm just going to solve it like a regular equation. So I'm going to subtract 1 from each side. 5x equals 35, and then I'm going to divide by 5. X equals 7. And if I wanted to check that, I could take that 7, plug it back into the original equation, and see if it works out. It should work out. Okay, number 5. So again, is there anything outside of this cubed root? And if there is, I need to get rid of that before I get rid of the cubed root. If there's not, then I'm going to just get rid of the cubed root. So there's nothing going on outside of it. There's a -16 below it, but I can't really get to it yet. So I'm going to get rid of the cubed root by cubing both sides. So you cube both sides to get rid of it. The cubed root of x minus 16 cubed is simply x minus 16. And that's going to be equal to 2 cubed, which is 8. Then I'm going to get rid of this -16 by adding it to both sides. So x equals 24. And that should be the answer. Again, if you want to check, just take the 24, plug it in here, and you'll find the cubed root of 8 does in fact equal 2. All right, number 7. I'm glad I'm actually getting to this one because this is where you actually have to do PEMDAS backward. So there's 2 things on the outside of this square root sign. To get rid of the square root sign, I have to get rid of those first. So I have to get rid of the 13 and the -2 before I get down to that. So the first one that I need to get rid of is the 13, because you start with anything that's being added or subtracted. So 13 is being added, I'm going to get rid of that. So I'm going to subtract 13 from each side, and in doing so, I'm going to be left with -2 times the square root of 24x equals -11 minus 13 is -24. Like that. Okay, so again, I need to get rid of this -2 before I get that square root by itself. Notice that's the next thing. It's being multiplied or divided. So it's being multiplied. I'm going to get rid of that by dividing -2 from each side. So I'm going to end up with square root of 24x equals -24 divided by that -2 is 12. And now that I've got this square root isolated, I can get rid of it. So to get rid of a square root, I'm going to square both sides. So I end up having 24x equals 12 squared, which is 144. Okay, And then lastly, I'm going to take 144 and divide it by 24 and get x equals 6. And that's my final solution. Of course, if I wanted to check, I can take that x equals 6, plug it back into my original equation right here, and the x, and it should end up equaling negative 11 when all is said and done. Okay, let's do 9. I like 9 because it's a cube root and it's got this fraction in the front, which tends to kind of scare people, but there's nothing scary about it. It's the same order of operations. So again, my objective, get that radical down by itself. But first I got to get rid of this 1/5 and that plus 10. In order to do that, order of operations backward, I'm going to get rid of that plus 10 first. So I have, what's left over is 1/5 the cube root of 3x equals, if I get rid of the plus 10, I just have to subtract it from each side. 8 minus the plus 10 is going to be negative 2. Okay, continuing on with this, I have to get rid of that next. When you see a 1/5 times something, that's the same idea as actually dividing by 5. So to get rid of a 1/5 times something, you need to multiply by 5. So I multiply by 5 on each side. That'll get rid of that. So I have the cube root of 3x equals this times 5. What you do to one side, you have to do the other. So that times 5 is negative 10. Okay, now I have the cube root isolated, so I can get rid of that. That's my whole objective right now. So I'm going to cube both sides. I'm going to be left with 3x equals negative 10 times negative 10 times negative 10 is negative 1,000. And then lastly, I'm going to divide by 3. So x equals, you can write negative 1,000 over 3. You can write it as a decimal like negative 333.3 continued. However you want to write that. That's going to be your final answer. You could check by just plugging it into your original equation again, number 9, and see that it does come out to equal 8. Let's see, do I want to do any of these other ones? Anything that looks like it might confuse you? Possibly this one right here. I think, yeah, there's something good to be explained on number 10. So let me fold this paper and we'll go to number 10. All right, number 10. That fraction is going to freak people out, but there's nothing intimidating about it really once you learn how to deal with fractions. So I need to get rid of it by adding it to the other side. Just the whole entire fraction, I'm just going to add it to the other side. Because right now it's subtract the whole fraction, so I'm going to add the whole fraction. So I get the square root of 2x equals 0 plus that fraction, so I have 2 over 3. Now the square root is isolated, so I'm going to get rid of it by squaring both sides, so I have 2x. Now this is something that I learned, it makes it really easy. When you square a fraction, you just square the top and you square the bottom separately. So 2 squared on top is 4, 3 squared on bottom is 9. Like that, 4 over 9. Okay, now to get rid of the times 2, I'm going to divide by 2. And if I'm dividing by 2, it's this fraction divided by 2. It's the same thing. Really, you're just doubling the bottom, because if you're dividing by 9 at first, now you're dividing by 9 and 2. So you're really doubling the bottom. Another way to think about it, so here's the answer, just before I go too much on the tangent. That's the answer. You can simplify that, of course. I'm not going to really worry about it for this video. I'm looking for an eraser. All right, well, let's see if I have one under the book. Okay, so here's the idea, though. I don't. So no erasing. Another way to think about this, when you divide by 2, is you're really just taking both sides and you're multiplying by 1/2. And the 1/2 will cancel. 1/2 of 2 is just 1, so those cancel like that. And then if you're multiplying 2 fractions, 4 times 1 is 4 on top. 9 times 2 is 18 on the bottom. I figured I'd just show you on this video because I know you guys struggle with fractions big time. So that's how you would do that. All right, going on to the next section. So this was all really just about isolating a square root. In this next section, it says to solve the equation and check your solutions. I'm not going to check the solutions. Well, maybe I will. Maybe on a few of them, but not all of them. What they mean by check the solutions is when you get a solution, go back, plug it in, and see if it actually works. Okay? So here's the big thing with solving in this section. Sometimes you get square roots on each side. I'll discuss those when I actually get to them. But the idea is the same. You really just want to isolate one of those square roots as much as possible. So for example, in this one, you're never going to have a completely isolated square root. Once you do that, you're going to, in this case, it's a cube root, so you're going to cube each side. So regardless, it's still the same objective. Isolate the square root or the cube root or the radical so you can get rid of it. But what happens on stuff like this, like number 15, is when you look at it, it's actually a first degree function. And due to the fundamental theorem of algebra, we know if it's a first degree function, it should have only one solution. So you start getting things called extraneous solutions. When I solve this, watch what happens. My square root sign is isolated already. I have x minus 6 equals the square root of 3x. Okay, square root sign is isolated. I want to get rid of it, so I'm going to square both sides. So people that are weak in algebra, let me go ahead and actually explain two misconceptions that they think when they're squaring both sides. One misconception is they think that when they square this, it's the same as doing x squared minus 6 squared. And they just put the squared on both the x and the 6. That's not the case at all. Okay? Another thing is when they think they're squaring both sides, they think they could just put a 2 here and put a 2 here, and they just kind of square the 6 only. That's not the case either. Remember, you square the entire side. So what you're actually doing is x minus 6 times x minus 6 equals the square root of 3x squared is just 3x. Okay, so remember, we started off with a first degree function. Now all of a sudden we're about to get into second degree functions because x times x is going to be x squared. Okay? X times negative 6 and negative 6 times x is going to be negative 12x. Negative 6 times negative 6 is positive 36. So you actually have to distribute this out. A lot of people call it FOIL. Multiply the first times the first, outer, inners, then the lasts. Doesn't really matter. What you really want to make sure you're doing is multiplying everything in this parentheses one time by everything in this parentheses. So what I do is just x times x, x times negative 6. Okay, I'm done using that. Negative 6 times x, negative 6 times negative 6. Then I'm done using that. What you'll end up getting is this. Okay, it equals 3x. I'm going to subtract 3x from each side, so I have x squared minus 15x plus 36 equals 0. Now the reason I set it equal to 0 is because we're no longer solving a first degree function. We're solving a quadratic. That means there's going to be two solutions. So the only way to solve these is maybe graphically. If you're looking for an x-intercept, you can do the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, all that stuff. Or you can just simply factor. Sometimes you can factor and it works out. But in all of those cases, you want to set it equal to 0 to do that. If you're solving a quadratic, set it equal to 0. I'm going to go ahead and factor. Two numbers that multiply to be 36 but add to be negative 15 are going to be 12 and 3. X minus 12, x minus 3. So what that's saying is my solutions are x equals 12, or, notice I use the word or, x equals 3. And the reason I use the word or is because my original equation, when you look over here, my original equation was first degree. That means I only have one solution, yet somehow I ended up getting 2. Okay, so I generated or fabricated this fake solution. It's called an extraneous, I hope I spelled this right. Extraneous solution. And the way you create extraneous solutions is in the midst of solving algebraically. If you go from a first degree equation to a second degree equation or something greater, you start building or fabricating solutions that were never there to begin with. So both of these are not solutions. One of them is a solution. And to find out which one, you take it, you plug it back into the original equation, which is this for the x's, and you see. So let's go ahead and plug in 12. Maybe 12 is a solution. So 12 minus 6 is 6. And then the square root of 3 times 12, 3 times 12 is 36. Square root of 36 equals 6. So 6 does equal 6. So 12 is a solution. Let's see why, real quick. This is the only one that I'm actually going to check, just because of time. But let's see why 3 is not a solution. So if I come back over here, and I plug 3 into here, I have 3 minus 6, which is negative 3. And then I have equals the square root of 3 times 3, which is 9. Square root of 9. So negative 3 equals, the square root of 9 is 3. Negative 3 equals 3, and that's not a true statement. So 3 is actually not a solution. It's the extraneous one. It's the one that you made up when you're doing the algebra. So just to kind of recap, sometimes when you're solving, if your solution or if your equation happens to go from a first degree function to a second degree function in the midst of solving, you are going to create an extraneous solution, and you have to check those solutions to make sure they're actually real. Okay, let's do a few more. So now I'm going to start doing this fast. The square root is isolated, so I'm going to square both sides. So when I square both sides, I end up with 44 minus 2x, because this squared, the square root is going to cancel out. Equals, remember this side squared is like this, okay? Which simply means that times itself. So you end up with 44 minus 2x equals, remember, FOIL this out. This times this times that. This times this times that. Okay, and when you do that, you're going to end up with this. Okay, it's not just x squared minus 10 squared. It's this. All right, so I'm going to subtract 44 from each side, and I'm going to add 2x so I can set it equal to 0. In doing so, I end up with x squared. So add 2x, that's minus 18x. Subtract 44, that's going to be plus 56. Factors of 56 that add up to negative 18, that would be negative 14 and negative 4, I believe. So 0 equals x minus 14 times x minus 4. Okay, so my answers, x equals 14 or x equals 4. So again, remember, we started this thing off with a first degree function. We ended up with a second degree function at some point in the algebra, getting two solutions. One of those is extraneous, because a first degree function should only have one solution. So at this point, I would take both of those answers, plug them back in, and make sure I have the actual correct solution, because one of those is a faulty, fabricated, made up solution. Okay, it's called extraneous. All right, new sheet of paper. Let's start doing tougher ones. Some of these you actually figure out are way easier than you may have made them out to be. So, for example, number 21, right here, I have a square root isolated, but it's also equal to another isolated square root. That's actually really fortunate, because what happens is, when the square root's isolated, you're going to want to get rid of it by squaring each side. But in squaring each side, the square roots are just simply gone. It's as simple as that. So you solve it from there. You're going to isolate your x's, get your numbers on the other side. It's just like algebra 1 now. So I'm going to subtract x from each side, so I end up with 3x equals, I'm going to subtract that 1 to the other side, equals 9. Or x equals 3. I can check that solution by plugging it back in. Notice, I am not concerned about extraneous solutions. I got one solution, and it was a first degree function, so I'm okay. It should be fine. When I look at number like 22, that looks a little bit tricky. It looks a little bit tricky, but it's very similar to the last one we just did, actually. All I have to do is, you see how it's a minus the square root of x plus 12? I'm going to add that entire square root to the other side. There's certain ways to do this that would take a long time, but if you realize what I'm just now saying, which is 3x minus 3 equals, I just added the entire square root to the other side. I have the exact same situation that I had over here in number 21, which is a square root equal to a square root. So I just need to square both sides. It ends up being 3x minus 3 equals x plus 12, and then I'll solve it from there. I'm not going to do it on this video. You guys hopefully know how to do it. I'll tell you about it. Subtract x, add 3, so you get 2x equals 15, so x equals 7.5. All right, let me do number 20. I like 20. So 20 would be the radicals isolated, so to get rid of that, I would have to raise it to the 4th power. So I end up having 3 minus 8x squared equals this to the fourth power. So that to the fourth power, remember, is 2x times 2x times 2x times 2x. Like that. So you end up getting 16x to the fourth. 16x to the fourth. Okay, so this is actually a really interesting situation. So here we go. I've got 16x to the fourth. I'm going to say minus 8. Oh, let's see. I'm going to add this to that side, and I'm going to add this to that side. So I end up actually getting plus 8x squared minus 3, and I set it all equal to 0. So the reason I'm setting it equal to 0 is because I recognize that this is a constant, this is squared, and this is a fourth degree. So I'm going to factor this, or attempt to factor it, like a trinomial. And this is actually going to be really nasty, guys. If you want to look at the factoring videos that I recorded previously in this year, then go ahead and do so. I'm not going to explain much on this. This is one of the ones where my a value is bigger than 1, so I'm going to have to multiply 16 times negative 3, and it's just going to get really nasty from there. So I'll go ahead and do it. I'll try to just not explain it too much. Again, if you want to actually figure it out or understand it, watch one of my previous videos on factoring. 16 times negative 3 is negative 48. Factors of negative 48 that add up to 8 is going to be, I feel like it's 12 and 4. Positive 12, negative 4. So positive 12. So remember, this is a fourth degree function, so it's x squared and x squared. X squared times x squared is fourth degree. So it's positive 12, negative 4. Now, because I multiplied by 16 at the beginning, make sure to divide by 16. I explain all this stuff in that factoring video. This is just a really nasty looking problem. Simplify that as much as possible and then swing over the remainder. So I have 3 over 4, so I'm going to end up with 4x squared plus 3 times, this is going to simplify to 1/4, so I have 4x squared minus 1. Now, let me just see, guys. I mean, that's some nasty factoring. Let me just see if that even makes sense. Does 4x squared times 4x squared equal 16x to the fourth? Yes, it does. Does 3 times negative 1 equal negative 3? Yep. Okay, chances are this is probably right. I'm not even going to talk beyond that point, but chances are this is probably right. If I want to actually find the solutions, I'd have to set each of these equal to 0, which is something nasty in and of itself again. So I'm just going to stop there, but setting each of those equal to 0 would actually find your exact solutions. Let's see, anything else? Number 25 looks like a really good one to work through. I'm going to work through this last one, and then that's going to be the end of this video. So number 25, the reason it looks like a good one is because there's no way to completely isolate a square root. And sometimes you can. This one's isolated over here, but this one has its little plus 1 on the outside. And if I subtract the 1, well then this one's just going to have a minus 1, and that one's going to be isolated. So there's no way to fully isolate one of these square roots. So let me rewrite the problem. 3x minus 8 plus 1 equals square root of x plus 5. Okay, so I'm going to shut the book. This is going to be the last one I do. Alright, so when I am actually solving this, because it's isolated as much as possible, I'm going to just go ahead and begin by squaring each side. When I square each side, this side, remember, it's the entire side squared. This side is just going to be as simple as this. Okay, but this side is this times itself. So let me write it real small. What that means is square root of 3x minus 8 plus 1 times the square root of 3x minus 8 plus 1. That's what I actually have to multiply out. And it looks really nasty, but it ends up being okay. It's not that bad. But this is the toughest type of problem you're going to have to do. This times itself right here is just going to be a simple 3x minus 8. That times that is just 3x minus 8. Now here's where it gets a little bit complicated. This times that is going to be plus 1 square root of 3x minus 8. And then 1 times square root of 3x minus 8 is going to be another plus 1 times the square root 3x minus 8. And then 1 times 1 is plus 1. I'm going to combine these because I have two of them. So and also look, I have a -8 and a +1. So what I actually have is 3x minus 7, because -8 plus 1 is -7, plus 2 of these square roots of 3x minus 8. This is the toughest type, that's why I wanted to put it on the end of this video. If you can do everything else but you can't do this, not a big deal, okay? You're doing fine. So I'm going to add 7 and subtract 3x from both sides so I can get this by itself. So when I add 7, that's going to be a 12. When I subtract 3x, it's going to be -2. So I end up having 2 square root of 3x minus 8 equals -2x plus 12. Hopefully that made sense. I got rid of this and this by adding 7, subtracting 3x from both sides. Next, divide by 2, so I end up getting the square root. I'm gonna have to skip some lines because you can see this like faint part right there on the video. That's the page kind of overlapped on itself, so I'm gonna skip some lines. It's gonna look weird. So I get the square root of 3x minus 8 equals -x, I'm dividing by 2 by the way, plus 6. Now I'm going to square both sides to get rid of that. So I have 3x minus 8 equals -x plus 6 squared. -x plus 6. Alright, multiply all this out, so I end up getting -x times -x is x squared. -x times 6 is -6x. And then 6 times -x is -6x. So I end up with -12x. 6 times 6 is plus 36. Equals 3x minus 8. And again, guys, I notice it's a quadratic, so I'm going to isolate it, set it equal to 0, and solve by factoring using the quadratic formula or anything like that. So I'm going to subtract 3x, add 8, so I get 0 equals x squared minus 15x plus 44. I'm looking for factors of 44 that add up to 15, and that's going to be 4 times 11. So x minus 4, x minus 11 equals 0. So my two answers, potential answers, are x equals 4 or x equals 11. Now again, if I go back to that original equation, I think, unfortunately I shut the book, but I think it was first degree. So, and if it was first degree, that means only one of these solutions is actually a solution. The other one's extraneous. So plug both of those into that original equation and see which one is a solution. But your answers are either 4 or it's 11. Don't know which one. Anyway guys, hope the video helps.